That's pretty much true. But they teach you some of it in physics. As long as you know the background trig, that's what they really, really, really need you to know. In fact, for a while they were letting people go to physics who took 178. And if you take 178, you don't have to take trig. So that was an evil thing for a while, but we fixed that.
I've definitely heard Calc 2 is the best preparation for Physics 1.
I don't know. All right, so let's see. So no questions? I mean, the partial fractions is going okay? And you're like, sure, as many as I've done.
You didn't do the long division, but I didn't have any of those on the homework.
Yeah, I couldn't remember. I didn't think I did do any long division stuff, but that's just a general thing about that process. Yeah, I don't think they have any. No. No, I don't see any in there. That's long division.
Any normal test.
Okay.
So you're not gonna.
Do you guys remember how to do long division?
Yes.
So the problem is you forgot how to do long division. All right, that's a more important problem. So I can't factor the bottom. So you can't even, I could if I wanted to use ugly, remarkably disgusting, complex numbers. So you don't even want to think about synthetic, trying to use synthetic. Synthetic only works at the bottom is linear, or you can factor it into linear, and it's known, so both counts. So to do long division, you just set it up as if these are numbers, mainly because they are. They're just not, there's numbers I don't know yet. Yeah, and then you just go into 10. You say, okay, x squared goes in x to the 4th, x squared times, and then you multiply. Yeah, minus x cubed.
2x squared.
Plus 2x squared, and then you change the signs. Alright? As I subtract this whole thing, so everything just changes signs. Is that should be all I have to do, because then after that it's going to be the same thing. Alright, so that. Bam, I get negative x cubed plus 4x squared. Bring down the negative 7x like you would as if they were numbers. Mainly because they are.
Negative x.
Negative and so forth. I mean, that's. So, let's see real quick. We can do this real quick. Negative x cubed plus x squared minus 2x. Change the signs. Die. 3x squared minus 5x. Bring down the 1, 3. So I get 3x squared minus 3x plus 6. Change those signs. I get negative 2x minus 5. So it'll be minus 2x. Let's see if you guys can handle that. Over. Right? And then these, if you were able to break up the bottom, you would take this is the part you'd actually do the real partial fractions on. And why do I know partial fractions would work? Because the degree at the top. And you're guaranteed that the remainder is always going to have that happen. So the long division pulls out the parts that you don't even have to care about because they're already known. They're already pieces. And then this would be the piece that you could break up if you could factor the bottom. That's the word I'm trying to use.
So that's where long division.
That's where long division comes in, because partial fractions will only work if the degree at the top is smaller than the bottom. So if that's not true, long divide, pull out the whole parts, and then focus on the true fractional parts, right?
Oh, no.
Fractions less than 1 anyway.
Cool. So then you just use partial fractions on the small.
Yeah, exactly. Yeah. Whatever's left at the end, that's the part you really care about. And then your answer will be this mess minus, and then whatever you broke up.
Okay.
There, cool. I like it. Cool. Does anybody else have the question about how to do the parametric stuff in the calculator? Is everybody cool with that?
Just that one would just be a. It'd be a over x squared minus.
No, you can't do anything.
Not to bring it into partial fraction.
No. On this specific one,
Yeah.
can you reduce the bottom? So here's the silliness. If you did try to do this problem here, wait for somebody to ask me about that, but it's okay if you don't. It would be over, I can't break this down, so what will go on the top?
A,
No.
X plus
AX plus
B.
B. Well, I already know A is negative 2 and B is negative 5. Then they should for me, right? I can't break it up, so I'd write it as it already is written, so I'd be done immediately, right? So I can't, if I can't break the bottom up at all, partial fractions will not do anything for me.
That's the only time that partial fractions would help.
Exactly, because once you break it up, then it can write each part in a specific way. If there are no parts, it would write itself. It's like, okay, there's no reason to do it. Yeah.
Can you say that once more? Just about how it doesn't go farther than that.
Because you can't break this up.
Okay.
If I could break this up, then I could put A over P plus B over P, but I can't, so it'd be that which is already is.
That makes sense.
Yeah.
But if it were still breakable, you would still have to use long division and then go to partial fraction?
Yeah, if it was a breakable thing, you'd do this, and then here you would break it up and then partial fractionize that guy. Right? Cool. Just a verb, that word.
Yeah, just need to hear it.
That's okay. I can say it. If you haven't figured out or don't know this, 10-8 is extra credit.
What is 10A?
Sorry.
10-8 is just where they give us systems of equations where you could have squares and cubes. So, since a system of equations in 2D is where two lines meet as the answer, then if I have like the equation of a circle and the equation of the parabola, it's still where they meet.
Just to meet more than one spot.
Just they could meet in more than one spot because one, of course, is turning around. Kind of with me. So algebraically, they could get a little more disgusting, but the funny thing is, you still use substitution, you still use elimination exactly the same way.
You don't use matrix at all?
You could if you had. You got to be careful. So
Because of the equation of a circle.
the reason I can set the matrix up the way I can is because the first column would be x, the second column would be y. So if I have squares and stuff, I better have a whole bunch of x squares and a whole bunch of y squares. If I have some x squares and some x y's and some y squares and they're not really matching, then there's no way to really set that up nice. Does that make sense? So you have to have repeated variable parts to make a matrix make sense. Okay. Let's see. So, if there's no questions on partial fraction stuff, do you guys want to see another example, or are you guys cool with it? I see some of you guys going, yes, please. All right. Let's see. What kind have we not looked at really yet? Well, let's do this one. This looks gross. Well, that's kind of evil. All right. Now the problem directly before this, the one I just said is evil. It's not this one I was saying was evil. They had this here, but it was factorable. Right? They had it written like this, but it was factorable. So the first damn thing I should do is factor it. Don't immediately go, oh, they factored everything for me. Let me put ax plus b over that. No. But this one, is this factorable?
No.
Probably not. No. So then I do have to set that up in the way I just said, right? It's an irreducible quadratic. So I have to put the linear term on top of it. 1 degree less.
Mm-hmm.
So how do I know this answer is
How is
going
that
to
not factorable? You got negative 18 and 6 and 3, right?
So if you have, yeah, it does factor. Negative 18. I didn't even try it. I didn't think they would do that twice. They did. 6 and negative 3. Yeah, that'll work. So how do you factor that?
2x.
Let's see, 2x, x. I need a 6, so I'll put a 3 there, so I'll get a 6. I need a minus 3 there. So I got minus 3 plus 6.
Uh-huh.
Sweet. That's to me, that's kind of stupid. I don't know why they did that twice.
Make it an 8. 2x squared plus 3x plus 8.
Yeah.
Could you pull the 3 out of the top before you went and did all that?
You
Yeah.
could.
I mean, but
Would
would
it
it help
change
you
the
at all?
answers or anything else?
Yeah, it would. I mean, you would solve it for that. You would get this.
And you multiply it
So
by
as long as you write it with a 3, and then you can bring the 3 back in. Sure. Yeah. All right. So let's try another one. That's my bad. I didn't even try that. I'm thinking they wouldn't do that twice in a row, and they did. Real quick before we leave this, since that is factorable, how would you write the solution? What form would it have?
A, B,
A plus 2.
A, B,
Let's be over that guy.
B,
Let's see over the
Let's
next
see over that guy.
X, something.
1, 2.
Thank you. And to me, that's a relatively easier one. I don't know if you guys agree with me or not. And the reason is there's distinct factors for each one of those. So I can just do the let x equal a number the whole way through,
Yeah.
right? So maybe let's do this one real quick. So how do I do the next step here?
Multiply by the.
Yeah, multiply by the LCD.
Yeah.
Right. I mean, you can do your 3 thing if you want to. It's not going to make it necessarily that much easier. Equals, so what's the A pick up?
2x minus 3. X plus 3.
Yeah, the other pieces. And the B picks up the other pieces. And the C picks up the other pieces.
So it doesn't matter that there's an x cubed out there then? Because the powers are the same.
So this is 1. What's the degree of the bottom?
3.
3. Okay.
Yeah.
I love it. All right, it's my bad. So the degree of the bottom is the same as the top. So officially on this one, you would have to.
Long divide.
That was a nifty problem.
Ha.
Oh, I see.
Tricky.
That should be a square.
Oh.
Oh.
Damn it.
It's not like I did that on your test. I'm quiet. But yeah, if that was a third power, then they would be even degrees. You would have to long divide it, which would be exceptionally evil because you have to re-multiply this out, and then that would be so evil. Okay,
You
so
like the bonus question?
thankfully that's no work done, so we're fine. All right.
X is negative 3.
Yeah, so now you just let x equal negative 3, for example, right? Because I can then kill this guy, and have c left, and so forth. Is that?
-2 and then.
Yeah, so I mean here, you would get negative 27 plus 9 is negative 18 plus 27 is 9. I think you did 9, is that right? I don't know if I'm going to trust myself anymore today. Yeah, negative 27 plus 9 is negative 18 plus 27 is 9. Here you get 0, 0, and you get negative 1 times negative 9, you get 9c. Looks like to me.
So C is 1.
So c equals 1. Alright. So does everybody get that idea? Now again, you certainly could multiply all this stuff out, collect all your x squared terms, all your x terms, and all your number terms, and then equate coefficients, make a system of equations. Not sure why you would want to. Yes?
Wait, I get why you did the, let x equal 3, and then on the left side you let the solution was 9.
Yes.
What did you do to get 9c alone?
So if I let x equal negative 3, what happens to this whole thing?
0.
Right?
Oh.
What happens to this whole thing? 0. And then I just plug in negative 3 in there, I get negative 1 times negative 9. So that's where the 9c came from. Yeah. That's why I'm doing this, because then 2 of my unknowns go away and I can focus on that one unknown. So I do it again. Yeah, let x equal negative 2, and then I can kill the last 2 dudes. So I get, alright, negative 12 plus 6 is negative 6 plus 27 is 21. Then those 2 die, I get negative 7 times 1, negative 7a. So a is negative 3, kick ass. And then again, the same thing for the last guy. Yeah, let x equal 3 halves. Oh, this is gonna be good. All right. So then you got 9, negative 27 force minus 18 force is negative 9 force plus 27 is something. Yeah, that's as far as I'm going at. But I mean,
Can you just connect them back in?
how do you mean?
A, B, C.
So on the other side, I'm going to get, if I let x equal this, these two die, because they have this.
Yeah.
So this guy's left alive, so I get, you could do it, Jeff. Can you? I don't know.
Believe in you.
3 has 7 halves times 9 halves. So I get 63 force B.
I believe in you.
That's where if you pull this through.
Yeah,
Negative
15
3
quarters.
times.
Not really.
You get
I still have the over 2 in there.
Well, yeah,
Well,
that's
you have
what it
81
is.
fourths over here.
Say again, sorry?
On the left you have 81 fourths.
81 force, okay, thank you. So then I get 81 equals 63B. So I get B is 9/7.
Okay.
Yeah, I gotta love it.
You sure?
Yeah.
Or else they'll get you. They'll find you.
What?
Alright. What's up?
I don't know, we're having a conversation
Oh,
and
that might
I'm
be-
not understanding.
I got a different
Don't
answer
listen to
than
him.
81 fourths, that's all.
Oh, okay. Alright. What's important there is just the process, right? So what made this semi-ugly was the fact that one of these had a fractional possibility, but who cares? If that's the biggest problem with the problem, then I love that problem. So let's try one. The one.
We applied for that one that
Hey, that should just be
equals 0.
1.
What's happening?
For 2x minus 3, couldn't we let x equal 0? Because A and B or A and C have that, and that would still be 0.
I don't understand. 0 would make this negative 9a.
Oh, yeah.
Yeah. Now, of course, another way to do this, if you start doing it like it's gross, I know what A and C are.
Yeah.
Right? And then I can go do that in other ways.
Oh, yes.
Right? If you wanted to
Yeah,
get that last one.
it should be just 1.
Fourths, yeah.
Yeah, so this is 63 force?
Yeah.
Alright, that's a little better. How much does that answer bother me at all? I don't give a shit. What I care about is that you understand the process, right? Do you understand how to do the problem? Kick ass. And so it's a much nicer answer, but who cares? You could get 9/7 there, who cares? Doesn't mean you're wrong, just means you got 9/7. Okay, so the kind of problem I was trying to get was something that's a little more interesting than that on the bottom. So you know how to set that up. So,
We did kind of one yesterday.
oh, here, gruesome. What's that?
Nothing.
Okay. All right. So you guys got all this? So if I have this here, I don't think we did this one yesterday here. Oh, cool. All right. I feel good about it. So what's nice is they've already factored the bottom for me.
Since it's bigger, you gotta do 1 division, right?
No.
Well, what's the degree of the bottom? 5th degree. Yeah, that's a 4th degree. So we're good there. Good check, though. You always got to check that out. So the 5th degree is smaller, 4th degree. And of course, what's this going to look like? I'm going to have a nice one.
A over X.
B over.
B X.
What's the degree of what's repeated?
Bx plus c.
Yeah, exactly. So you need a linear on top of it,
And then
but then it's repeated, so you need.
Bx plus C.
dx plus
dx
C
plus
over x squared plus 1 squared.
Tubular. So you can imagine, you get a lot of freaking letters going on. All I had to do is make this a cube. And all of a sudden you got 2 more letters out there, right? Because then you need a cube on the top, of, a quadratic on the top of it. So forth. So, I mean, the process is still the same. What's kind of gross about this, though, compared to how we did the last one?
Factoring or distributing.
What would you let x equal? Can you think forward? The only one you could do would be 0.
0.
That you can't factor using real numbers. You could still let x equal I or negative I. I don't know if you want to.
No.
Actually, not as bad as it sounds, but it's still bad. So here, of course, the next step, I'm hoping you guys can do this next step without actually having to do anything. What would this guy pick up? And these are people make mistakes though, so x squared plus 1 squared, exactly. Because that's what it would need. It already has an x, don't put an x there.
And then B picks up X.
Yeah, he picks up an x and an x squared plus 1. Because he only has one, so he needs one. This guy, and he needs one more of those. And of course, the last guy just picks up make an x jump. Okay. So the way I would do this problem is I would let x equal 0, figure out what I can, plug it in, rewrite it, and then the rest I've got to do equating coefficients. Does that make sense?
Yeah.
So that we did a problem like that. We did part of it, the let x equal a number way, and the rest of what we had to do the system of equations with. So if I let x equal 0, I'll do this side. What do you get over there? The last two ones, of course, die. And you just get
1A.
A. Sweet. So A is 1. Kick ass.
Yeah.
Now, here's the partially bad news about it. It's not that bad. If I want to actually use that information, I can replace this with 1. And now I want to subtract that, which means I really have to FOIL it out, right? So then I can put it together with stuff over here. And here's what's really nice. Oh, see, crack. So here's x to the 4th plus 2x squared plus 1. FOIL out. And then subtract that over. You guys cool with what I'm doing? The minute I know, it has to if you think about it.
Oh yeah, okay.
That's
So
where
it's
you're
taking
gonna
an
get
x
X to the
out.
4th.
Yeah.
So here's x equals 0. So now subtract all this stuff.
Minus 1.
Oh, yeah, thank you. And then, so that's away now. So now I have x cubed minus x squared
minus x.
minus x equals. And again, it makes sense that this canceled too, because in this whole thing, the only constant, now you see how everything here would have an x on it?
Yeah.
Yep.
So the only way I get a constant is a, and since a is gone now, this guy had to go. He had to go. Let's see what we got. Equals this mess here. So now I got to multiply this stuff through.
So EX cubed.
Yeah, bx cubed plus cx cubed
DX.
plus bx squared plus cx. Something like that.
Well, what did we get?
bx to the 4th, yeah,
X to the
thank you.
4th.
bx to the 4th. Let's do this. So
Yeah.
bx to the 4th plus bx squared plus cx cubed plus cx. Alright, cool. So just multiply all this stuff out. Now I can collect all of my terms, right? So I only have one x to the 4th term. What's going to happen to that 4
It's
dude?
going to be 0.
So that's awesome. So now I know b is 0. I can forget about him. I've only got one x cubed term. So what's got to be true about c?
0.
Well, what do I have over here though?
1.
Oh, 1.
1.
Yeah, so c has got to be 1 so that this actually works.
Yeah.
The idea of equating coefficients is almost too easy to trust, but do it.
So then D's negative 1?
And what did we say about b already?
It's 0.
It's 0. So I can figure that. So d's got to be negative 1.
And E's got to be negative.
And e's got to be negative 1. That kicks ass. So the answer will be equals 1 over x plus 1 over x squared plus 1.
Wouldn't E be negative 2 because you gotta add the CX,
It is negative.
which is a 1.
Yeah, here we got cx and ex. There you go. Cool. All right, let's see. So c plus e has got to be negative 1. So since e is
C is 1.
is 1.
c is 1, subtract that, you get negative 2. That's better. So e is negative 2. So then you get here b is 0, c is 1. And then you got D is -1, and E we just got right is -2. So you just throw that all back in. So that's how you break that up. Cool. Thank you for that. Okay. Not too terrible. Now you can imagine these can get gross, and again, like I said, if they do get gross, where you have a whole bunch of stuff, you can't use this at all, and you end up with A through J. What you normally do is you just construct the matrix of all the systems of equations you get when you equate coefficients. Throw that bad boy in the calculator, let it chomp on it. All right, then just take the answers. Chris?
I was just trying to see how C or E equals -2.
So the thing here was there's two x terms, right?
Okay.
So C plus E has to be -1. We already knew that C was 1,
So you plug it in.
so you plug in 1 and then you solve for E. Yeah.
I'm not sure.
Okay. All right. So what I want to do the rest of today, and this is good because I just wanted to do an overview of Chapter 11. Anybody not get the handout from last time for 11.1 through 11.3? Yeah.
Almost done. Working on that. I don't know if he's actually puts that on there.
What's up?
K8.
Yeah, it's up there.
Really?
No, I'm lying to you. All right. I'm a horrible liar. I immediately tell you more. So this is, parabolas themselves are pretty consumingly easy. But when you want to construct, like a satellite dish, or you want to construct parabolic spotlight.
Is
Right.
that someone that's such a uniform?
So, yeah, he is.
Okay.
I love that. Right, he's proud with his interests. So the nifty thing about parabolas, the shape. If I put, so very often you'll have like telescopes that are shaped parabolically, because when the light comes in from very far away, it will always gather at a single point in the center, which is called the focus. Now, if I use that the opposite way, and I have a light shining this way from the focus, all of the light beams will come back out in a straight line. So then you get a very focused light beam. So then you can just throw that overhead and say, something's happening downtown, yay. Right? Okay. You don't need to know that. So this is, so the definition gets a little strange, but I want to define, like a circle's definition is very, very simple. A circle, just to remind you guys, we're not going to do all the derivations of all these other ones, but a circle, what's the definition of the points that lie on a circle? Who can tell me? Not the number. Beautiful, that's it. They're all the points that are equidistant from some point we call the center.
Do you want
Right.
this based on that?
Maybe, now I do. Thank you. All right.
Dark. Oh, there goes light.
Yeah, it takes a second. So if I call some point the center, and then I say, okay, let's just go out some distance, I don't know, we'll call it R. And I say, okay, there's one point that's equidistant. And of course, if I go out to all the points that are equidistant, I will trace out a circle. Now, of course, if I say the distance from this center, we'll call it, well, let's do it more interestingly. Let's call it HK. And some arbitrary center. And I say the distance from that to all the points has to be the same. Set up the distance formula for me. What would that look like?
Y minus
Let's do d squared, so I don't have to be big.
Y1 plus Y1 minus K plus X1 minus, was that H square root.
Yes, and of course the distance would be
not squared.
r. So it's r squared is x minus h squared plus y minus k. And we should notice that's if I have a unit circle, it's this.
Don't we square root that? The distance?
If I wanted to get rid of that,
No,
but
I
I
was
don't.
talking about the distance one.
Yeah, we have to-
You generally do, but very often you don't. If you don't want a big ass square root, you just don't. So there's the unit circle centered at 0, 0. If I want to move the center, we know how to shift things, right? This would move it over h and this move it up k, or depending on what h and k are. And then I can just change the radius. I mean, so that's the developing the formula from a definition of the points I want to catch. So if I want to do the same thing to a parabola, and the reason I want to do that is because then I can find out other aspects about it that would help me in design. So I can design it better.
Okay.
Because we get stuff like the focal diameter, which wouldn't mean a damn thing if I just looked at parabolas the way we have before. The definition is, if I set up some line and I set up some point, then it's all the points that are equidistant from this point in that line. So for example, there would be a point here that's the same distance from there as it is from there. You guys get the idea? Mm-hmm. And then the minute I start to, I can't just move straight over, because then this distance is the same when this distance gets bigger, isn't it? Yeah. So I have to get a little bit away from this down here. I have to be really kind of fat, so that this distance grows a little bit while this distance grows the same amount. So you can kind of just take that idea out, and you end up getting that in both directions. So here's a little animation considering this stupid computer won't run Java, so I couldn't show you the one I actually had. I had to go find Star Trek, dude. To do this. Oh, 240p, yeah. So, I mean, there's the idea. You can see the blue lines are the distances from the focus, and the directrix is what this line is called. And that's just the basic idea. And there's all of this other stuff. So that these blue lines have to be the same length. So as I move away from this middle point here is kind of like the most trivial point. I almost got it. Alright, that's almost there. Oh, stop. But when you have this little middle point, that's kind of like, okay, that determines the vertex then. The one that's the same distance from the focus as it is from that line. Is that cool? And then the minute I want to move over, I can't move straight over. I've got a curve. Yeah, you're going to be bouncing all over me.
I got it.
Okay.
It's like I got my helper back.
Let me talk a little bit more about parabolas here. Let me see. Gotta see how much time I got. So one interesting little thing, there's a point that's like right across from the focus here. So if I call this distance P, right?
Oh, it makes a right triangle?
Yeah.
So then, this is kind of interesting. So, in fact, let me make sure you understand. I'm calling this distance to the focus P.
Oh, okay.
So then, what would this distance here have to be?
P.
Because again, the definition is the distance from here and the distance to there are the same. So that would have to be P. So right at the focus, what would I call the focal diameter? If I go all the way across, how long is that? 2P. That's it. If it's P there, it's kind of like a radius, right? So if I want the diameter at the focus, it's 2P.
The focus is when it's a 90-degree angle.
No, focus is the central point.
Focus is actually something I define before I even start tracing my parabola. It's a point and a line. Put them any damn where you want to, and then do that. And that's where the parabola comes from, right? But I'm going to call this distance between those, that standard distance between the focus and the line, I'm going to call it P. So then this has to be
2P.
2P. Okay. So today, just to make sure you guys understand, we're just doing an overview. I'm going to move on to ellipses and hyperbolas. And then tomorrow, we're going to go back in and focus on each one a little bit more. Today, we're not going to look at it so detailed. So looking at an ellipse. And the standard thing you get with an ellipse, I don't know if you've ever seen this. I think they have this in the book on page 733. It's where you have these two tacks you can put down. And you put some string in there, and you put a little pencil in there, and you kind of trace it out. So it kind of, by doing that, it restricts where your pencil can go. So the definition of an ellipse, so I've got that written down. I shouldn't have to write it. So on the handout in the middle of the page, it's the set of all points. The sum of the distances from these 2 points has to be equal. So if I'm here, this plus this must be a certain number, and it must be maintained as I move around. So as this distance gets bigger, this distance has to get smaller. And then when that's the biggest it could be, this must be the smallest it could be. So that sounds a little bit like planetary motion, right? Or even as we move around the sun is actually at one focus of this big ellipse that we go around the sun with. Okay? And the closer these 2 points get, so if I put them decently far apart, I get this really skinny little ellipse. If I push these closer, and the limit that they become 1 in the center, then it becomes a circle when it's just 1. So I'm just going to pull that center apart, and then the circle gets flattened. Or I could do it this way, and the circle gets elongated that way.
So, explain how that. I mean, I got the ellipse part, but as far as the whole triangle, how you were trying to explain that part.
So it's not really a triangle. I'm putting a pencil here,
Okay.
and this is string, so the string is kind of like pulling me
Where's
in.
the string?
So this is
the
on
2 points.
page.
It's connected to the 2 points.
Let me put it up here.
Oh, okay. Never mind. I got it now.
You got it? Okay.
Yeah.
I know.
Shoot.
Where's the string?
Basically,
It's attached to the 2 points.
Yeah, it's attached to 2 points. So as
And so
Good.
then you put the
It's attached
pencil
to the 2 points.
in the string and
It's a
pull
little
the string
bit-
down. The
A little bit
string,
loose, so you put your pencil in there, but as you turn it around, they kind of pull you back in. As they get further this way, more of the string is there, so less of the string can be here, and that's what pulls me in. And if I move it this way, same thing will happen, but just up and down. So algebraically, if a circle, let's say, a basic circle is that, I know it's a circle for 2 reasons. It's plus, so minus something interesting happens. And the coefficients are the same, so it's symmetric in both the x and y direction. So to make it an ellipse, the easiest thing I can do is just to,
Change coefficient.
yeah, if I put a 9 there. Now think about it real quick. Which letter can't go as far as it used to be able to go? How do I say it?
why?
Well, y can go further. Let me say it that way. 9. So if I do it like this, how do I do it? No, this is
Oh, because, okay.
x is going to have to be smaller stuff, right? Because times 9, it's got to come out to be 1. So if y is 0, x would be 1/3, for example. You guys with me?
Yeah.
Okay, so then we'll get into the more specifics about if I put this in a certain form, like this, I can tell exactly how far it goes in the x direction and in the y direction. Okay, cool. So the only difference really between an ellipse and a hyperbola, algebraically, and the equation is, a hyperbola would just have a minus there.
So just a general
it's a
question.
hyperbola.
Yeah, it's a hyperbola,
Just a general question. We're moving away from trig now, correct?
in a way.
Okay, yeah.
Yeah.
I don't.
So that would be an ellipse. If A and B are equal, that would be a circle. And then no matter what the hell A and B are, that would be a hyperbola. Even if they're the same, it's still hyperbola. Hyperbola is kind of the opposite of ellipse. An ellipse is the sum of these distances must be equal.
The difference.
Yeah, and a hyperbola, the difference of those distances have to be equal. So there's a decent little animation. I didn't do the 4 little. Here's the ellipse one. I kind of like that. It's got the red distance and the blue distance have to be the same. So as the blue gets longer, the red gets shorter, and vice versa. And then for hyperbola, these 2 distances, see over here, take the difference. So as this one gets smaller, this one also has to get smaller, right? And now as one gets bigger, the other one has to also get bigger. So it kind of pushes it away. So the differences have to be equal. So if that D1 gets bigger, D2 has to get even bigger so that the difference stays the same. So it pushes it away like that. As it comes in, it pushes it. It goes, go away from it. So you can have comets that are in hyperbolic orbits, for example. And you have comets that actually are in elliptical orbits, and they keep coming back to say, hey. All right, so next time we'll get into, obviously, just a little bit more